equations given by that. Find the velocity in t is 1, so you can stick 1 into here. So that's 1 squared, minus 4 cubed, so that's 1 minus 4 is minus 3 cubed, gives us negative 27 meters per second. Oh, I wrote it units the wrong way. It's negative 27. Find the value of t for which the particle is at rest. If it's at rest, then the velocity is 0, so 0 equals t squared minus 4 cubed. So that would be cube root both sides, so it gives 0 equals t squared minus 4. So t squared equals 4, t is plus or minus 2. Find the total distance the particle travels during the first 3 seconds. Just a reminder that the total distance travelled is given in here. So we are finding so C is between 2 and negative 2, t squared minus 4 cubed. So integrating that gives t squared minus 4 over 4 times 2t. What am I doing? It's calculator paper. So that's 9. So negative 2, 2. Let's open up bracket. Squared minus 4 close bracket power 3 gives us 1. Oh, hang on a minute. What have I done here? Oh, total distance during the first 3 seconds. Oh, my house is seriously. Okay. So, actually, what we should do first is check that it's all, because remember it's the total distance, so we need to check whether any of the graph is underneath the curve. So if we just graph it quickly, clear. So we are graphing. Okay, so we can see that some of it is below, some of it is above. Okay, so in the first 3 seconds, so we can see here this is 2, so we're going to want to do between 0 and 2, and then between 2 and 3. So let's grab that. So we want to find 3, 0 of t squared minus 4 cubed dt, but we're going to separate it into 0, 2 and 3, 2. So 9, okay, 0, 2, So that's 58.5. Obviously you're going to do this much neater. And then enter again. It's going to be now 3. It's going to be 2. 27.7. Add those two together. What was it? 58.5. Gives 86.2. Ooh, should we have been... Shouldn't have rounded quite so much. So 58.51428 plus 26.7. So it rounds to 86.3. Yes. Show the acceleration as given by that. So we know acceleration will be the derivative of the function, because remembering that link between displacement, velocity to acceleration. So we would differentiate. So we're differentiating this function. So this is part D. So we've got, what was it? Oh gosh. T squared minus 4 cubed. So power comes in front. Taking off power and then multiplied by the derivative of what's inside. So 6t t squared minus 4 squared. There we go. Find all possible values of t for which the velocity and acceleration are both positive or both negative. So, to be honest, I think the easiest thing, because we need to find whether they're both positive or negative, is just to plot them on the same graph. Oh, I've already put that one in. Great. So 6 t bracket t squared minus 4 squared. Okay, let's look at between 0 and 15. Let's try that. Let's keep with that. Let's graph it. Right, let's change our window. What is going on with this Y graph? Alright, so we need to know when they're both positive or both negative. Oh, perhaps I should change that a little bit more. Perhaps 50 was a bit too excessive. Okay, we're changing both to be negative. Okay, so this one's negative down here, this one's positive. So they're both positive here, so that's between the values of 2 and 3. So E is between the values of 2 and 3. Oh,